So why could getting enough energy be a limit? Well, let's think through energy processes involved in turning food into physical activity. There are a whole bunch of different steps. One, we find the food, and that could be a limiting factor. We did most of our evolution in prehistoric times, so finding the food presumably indicates chasing down some wildlife or gathering nuts and seeds. And that all takes energy. There aren't that many prey to eat around. Could that be a limiting factor? It's not today. It's easy to get high kilojoule food, but in prehistoric times it might have been. But then on the other hand, let's imagine you were 10 times stronger than everybody else because you had a high energy rate. Then you'd probably find it a lot easier to get the food. If nothing else, you could steal it from all your slower companions. So it's not obvious that's a limiting factor. Then the food goes into your stomach and has to be digested. And also we need to get in enough oxygen into your lungs. Now we know that you're breathing very hard, panting when you do a lot of exercise. So getting enough oxygen might well be a serious limiting case. Once you've got the food and the oxygen into your bloodstream, it has to be pumped by your heart to the muscles. And we know that your heart beats faster when you're exercising. So there's a lot of very narrow pipes, capillaries and veins, and you need the heart to pump things through. However, it turns out the power of the heart is only about 1 watt, less about 1% of the total human energy output. So this is not a major problem, it turns out. Then you've got to actually metabolize fuel. And we know that that's relatively easy because we know that cells in mice metabolize at 10 times the rate of humans. So that's not a limiting factor. Then you've got to get rid of waste products. That's carbon dioxide and the other remains of the food. That's presumably going to be rather similar to circulating, since it's done by the same systems. It's not a major problem, that the body can handle that. If need be, you just have wider veins and more of them, or a higher pressure heart if it was getting to be a problem. And then there's getting rid of waste heat. Remember that muscles are only about 25% efficient, so for every joule of power you use to run, 3 joules of power have to escape somewhere in the form of heat. Or they can just heat you up. And we know that you get very hot and sweaty when doing exercise, so that's clearly a bit of an issue. So what we're going to do in this section is investigate 3 and 7. These are probably the most important ones, but some of the other ones might be an issue as well. But these ones are the crucial ones. How can we get enough oxygen? And how can we get rid of the waste heat? And it turns out that one of these, possibly both, are going to be the things that really seem to limit the performance of humans.